Hello friends, welcome back to Arctic's 8-Bit Bytes. I'm really glad that you're here. And if you're into AV engineering, programming, and a little bit of nerdy deep diving, you're in the right place. Lately we've been exploring everything from Netgear AV switches to Crestron MVX, and yes, more Crestron content is on the way. But today, we're heading back into one of my favorite platforms, the QSC Q-SYS and Lua scripting. When you move from block controller to text controller and you start programming in Lua, something big changes. You are now responsible for your own connections. This means building your own Ethernet drivers, air handling, and making sure that your code doesn't crash when things go sideways. So in this video, we're going to build a custom Ethernet connection driver from scratch, step by step, to talk to third-party devices. And I've had a working version for a while, but we're going to break it down and build it together. And honestly, well, making this video, I even learned a few things that I didn't fully understand before. So real quick, I'd like to say, if you're enjoying this channel and want to see more AV engineering and programming content, make sure that you hit that subscribe button in the bottom of the video. It helps the channel to grow and keeps these videos coming. Now, a few quick disclaimers before we dive into programming. These videos are geared towards new Lua programmers like me. And this Ethernet driver is written in the most beginner-friendly way possible. And yes, it absolutely could be written shorter or more elegant by using more advanced Lua techniques. But we're going to keep it simple. And there's room for improvement in error checking and variable handling, like making sure variables aren't nil and bulletproofing your code for real-world use. And hey, I make mistakes. I make lots and lots of mistakes. And you'll probably spot a few. And in fact, after recording this, I went back and found a couple. And while I was recording the video, I had to go back, and part of the video was fixing stuff. So the awesome thing about having errors and needing improvements is that towards the end of this video, we'll do some error checking using Microsoft Copilot. And Copilot, or whatever AI you choose, Grok or Google AI, they are all amazing resources, and we should be using it for our programming and error checking. And don't get me started on AI, but all I can say is it's coming, and this is just the beginning. I have this video broken down to 13 simple steps. So let's dive in and let's do some Lua programming. Okay, step one. We need to grab a text controller block from the components menu, and we're going to create several buttons that's going to interface with the Ethernet driver program. Yep, there's our text controller. Drag it into the design. Hit the plus to create 6 buttons. And the first 2 are going to be text boxes, and this one's going to be where we put in the IP address, and then one for the port number. And then the next 2, we're going to have like a status text box where we're going to have the Ethernet status. And then this status is going to be a momentary button where we're going to change the colors, like green or red, depending on error checking. And then the last 2 are going to be buttons that are going to trigger sending commands to our device. So we're going to make those state triggers. Yeah, bringing in a momentary. It's a text box, text box, text box. And then we're going to go back through and double check and make sure that we got those all right. Okay, looks like we're pretty much all set. We're going to move on to the next step. Okay, step number 2. We need to go to the help file and go to Q-SYS extensions to Lua. QSC has created a big library of extra commands that they've added to Lua, which gives Q-SYS some extra functionality. So, under the help file, type extensions, and using Lua and Q-SYS. And one of them is a library of TCPsocket commands, or Ethernet connections. Their TCPsocket is where we need to be. And this will show like all the different functions and methods, and callbacks are like the error handling. If something happens with the Ethernet connection, a callback is triggered. And so is connected or reconnected or data showed up on the Ethernet, that's a callback. It triggers a section of code. Different properties. And at the very bottom, there's examples. So they've given us some examples. So we can use one of those as a basis for our module. One example is a single event handler for all of the events. Or there's what's called separate callback, which is each event triggers its own group of code. So that's what we're going to use. We're going to use that as a basis for a module. So let's copy that. Step 3. We need to take the code that we just copied from the extensions to Lua help file. and we're going to paste it into our text controller block. And we're going to make a lot of changes. So we created 6 buttons in our text controller, and the first 2 were text boxes, so we can put in the IP address and put in the port number. Now we need to grab that information from those controls and assign them to the variables called address and port. As part of the socket connect command at the very bottom, that port needs to be an integer. So we have to use the toNumber command to convert the string to an integer. And below that, socket equals TCPsocket new. That's what actually creates the new Ethernet socket. And we're being original. It's called sock. And then below that is some timings, like how long does it take before it times out if it tries to read data. And the default is 0, and depending on the device, we might have to change the timing of that. And then the next thing, send data. We're going to delete that because we want to send it our own commands with power on and power off. Okay, step number 4, Q-SYS callback functions. And really it should say Ethernet or TCPsocket callback functions. A callback is basically a trigger, or it's kind of like an event handler. Whenever that event happens within the Ethernet port or the socket, it triggers that block of code. So if you receive data from a device, that code runs. If it connects, then that runs. So we're going to go right on to step 5, which is receiving data. So one of the callback functions was sock.data. And whenever we receive feedback from a device, or any sort of response, it triggers that group of code. So what we're going to do is we're going to grab that, and we're going to create our own block at the bottom. We're going to pull it out of there. We're just going to use the top for connected, disconnect, and some of the error handling. I'm going to put a little note, data has been received. And the first thing that we want to do is we want to pull all the data from the buffer, and we're going to assign it to a variable called device feedback. That sock.read command, there's another command, see the sock.bufferLength? It basically reads the number of characters that are in the buffer, and it then grabs everything out of it. But the sock.read command, or the sock semicolon command, you're supposed to give it the number of characters that you want to grab. But by using it that way, it grabs everything. And then we're going to use another command called string find. And we're going to have it look at that device feedback variable, and it's looking for the group of characters that we put in there. That would be like the power is on feedback from an LG TV, or whatever command that would be a response from a device. We're using the hypothetical power is on feedback. Now under controls, we want our power on and power off buttons that we created, the state triggers, we want them to light up. So that's what the 1 and 0 is, and if the power is off, we want power off to light up. Okay, we need to copy that for the power off sequence. That needs to be a 0. That needs to be a 1. And by the way, something happens halfway through me programming this, and some of those get screwed up. So my error that I was talking about at the beginning, we got to actually go back and fix some of this. But right now, it's actually right. So. Okay, step 6, event handlers to send commands. So 2 of the buttons that we created in our text controller were power on and power off, and we made those state triggers. When those buttons get pushed, we want to send commands out the Ethernet socket to that device to turn the TV on or turn the TV off. So we have to create event handlers to make that happen. Button presses, do something. So we're going to do the controls, power on, event handler, and then we're going to introduce a new command that is sock.write. And then if sock.is connected. Basically, we don't want to send data out of a socket that hasn't been connected because that'll cause an error. So that's a little bit of error handling there. Yep. Sock write. And then this is our LG TV is on command. And then now, yeah, let's create one for the power off. There we go. Okay, step 7, colors and status. So we have the two blocks, status text and the momentary button that we created in text controller, that's status. And then we have our callbacks, is connected, reconnect, close, all that. Basically, when those events are triggered, we want that data to be reflected on our blocks that we created. So controls, status text, string, we're going to say socket is connected. So you'll have that information when it connects. And then the other thing is we want to create that momentary button. We want to change its color. So legend, we're going to actually, in addition to changing the color, we're going to have the legend of the button say OK or error, or, and then status color. And this is where we get to use the hexadecimal numbers. So it's red, green, blue, and hex. So 00 is black, FF is green, and then 00's. That makes sense. You can use AI if you can't figure out those colors too in hex. And then also I noticed the other day, like if you're within Q-SYS and you go to that palette wheel and you select a color, it tells you the hex at the top too, so you can copy it from there. And then, yeah, so reconnect, we want to make that yellow, and then we're going to have ... on the button saying still connecting. Close, the socket is closed. And I think we're going to make that red when the socket is closed. So when the socket is closed, it's bad. None. None for you. And then 808080, that's gray. I had to figure that one out. I didn't just like make that up and pull it out of nowhere. That's error, and then we got one more, which is timeout. But it's good to have this data on the front end of your text controller block. It's always exciting when you get a green button saying, I'm happy, I found your device, here you are. One more, okay. And error is bad. So that one's going to be red. Guaranteed. Timed out. Okay, let's move on to the next step. Okay, step 8. Event handlers for IP address and port. Basically what these are going to be is, let's say I want to change the IP address on the fly. Well, the way the program is currently written is it only grabs the IP address and port when the program runs one time. But what if, well, the program's running, I want to change the IP address. Well, when I change the IP address, I want it to re-grab that data and assign it back to the variable. So we need to create event handlers if the IP address or the port change, and that way it can reassign the data back to the variables. We're going to stop the query timer. Yep, disconnect the Ethernet socket. Reassign the address variable to the control. It's basically, it's saying, hey, the IP address changed, so we need to, boom, trigger this block of code, reassign the address and port variables, and then let's reconnect the socket. And I actually have one error here. I really shouldn't be stopping and starting the query timer here, because when we reconnect the Ethernet socket, that callback is triggered, and part of that callback is to start the query timer. So yeah, you don't need the query timers stop and start in this event handler. And the funny thing is we did some Copilot error checking there towards the end, and Copilot caught it. Copilot's like, hey, this doesn't make sense. I'm like, oh, you're right. Crap. Okay, now that we have the IP address and port event handlers, we're actually going to add a little bonus here. We're going to add a query timer. Basically, we're going to create a timer called query timer with a timer.new command. And when the Ethernet connection connects, we're going to start that query timer. We're going to give it a tick of every 5 seconds. So every 5 seconds, it's going to trigger its own event handler. So we're going through our callbacks here and reconnect. We actually want to stop the timer with all of these. You know, if the connection is closed, we want to stop the timer. If, you know, there's an error. So we're just going through and stopping the timer on all those callbacks, and we're starting it on the connection. And then also the whole IP address port event handlers. If you change the IP address, we don't want it to keep querying the device when the device isn't there. So we're going to start and stop the timers as per the IP address and port whenever those change. And then we need to create its own event handler. So whenever every 5 seconds, whenever that triggers, it will run a block of code. And what we want it to do is we actually want it to query the device saying, is your power on? Or what's your input? Or whatever query commands you want to send it. So query timer, event handler equals function. And then just to be safe, I mean, technically the query timer shouldn't be on if there isn't an Ethernet connection. But we're at least going to say, hey, if the socket isn't, something happened, if it's not connected, let's not send that query command, because you'd be sending a write command to something that's not connected, and that would cause an error, and we don't want to do that. So, and then yeah, we just use the generic query feedback command, whatever that command might end up being. And there you go. Now we have a query timer. Step 9. Oops, I made another mistake. Imagine that. So, as the program is written, the very first time you run this program, you haven't had a chance to put an IP address or a port into the text controller block. So the program is going to immediately try to connect with the socket connect command with no data in the address or the port variables. And it's going to immediately cause an error. Now, technically, once you put that information in, it's never going to cause that error again. But what this block of code does is it says, hey, if the address variable and the port variable is equal to nil, then let's just assign them temporary values. So when it tries to connect to the socket, even though it's not the right IP address, at least the Lua program doesn't error out. So it's a little bit of error checking here. And there we go. On to the next one. Step number 10. Oh, crap. Copilot found another error. I actually mentioned this error earlier. I think this was a copy and paste error, but just go into your program and make sure that under the data callback that those values are correct. Power on goes to 1 and power off goes to 0. And somehow my version got messed up, so make sure that yours is good to go. It probably is. Okay, on to the last couple steps. Okay, step 11, the Copilot final error check. So what I'm going to do is I'm going to go into Copilot, and you say, Copilot, I'm programming in QSC Q-SYS Lua, and I have a program that you would like to error check. And I'm going to copy and paste this program to you, and you got to tell me how much I suck. So just be descriptive, though. You got to tell it not normal Lua. You got to tell it what you're doing. And then just say, here's the program. And it'll say, really, you kind of did this stupid, and you screwed this up, and thanks for sharing your Q-SYS Lua script. What looks good? Okay, it says timer.new and all that fun stuff, and potential issues and suggestions. Initial connection might fail silently. it's suggesting some error handling. And it suggests, hey, what if this variable is a nil, and some other stuff like that that you're like, missing query timer stop on disconnect. We'll make sure that it still has that. No error handling for toNumber. Yeah, it's basically saying, like, what if it can't convert that string under port to a number? Then that might cause an error. Yep, so it actually recommends, hey, you could put this block of code in. Redundant code in IP port event handlers. Yeah, so basically, I put in the code, hey, if you change IP address, if you change the port, but then I reassign both IP and port depending on. And then it's suggesting, hey, instead of using the string find command, use the string match command. And this is where it says, hey, you really shouldn't be starting and stopping the timers based on the event handler of the IP address changing. So it's pretty crazy what it recommends. And it's pretty spot on. I'm basically showing here, hey, when the socket connects, I start the query timer. So don't mess with the query timer under the event handlers for IP address and port changing. And I'm just showing again some of the error handling that I already put in there. Okay, step 12, Hercules. Test the module with a TCP server. So I messed around with like taking a Crestron processor and trying to make a TCP server, but I figured out, you know what? Let's just use Hercules. Hercules has its own TCP server tab. So basically, on our text controller module, I'm using the 127.0.0.1, which is a computer loopback. And then I'm creating the port 5000 in Hercules. And so as I push the buttons, I can see our module that's trying to send the feedback out. Power on command, power off command. And then down there, I can actually send simulated feedback back to our text controller and see how I can basically text controller saying, hey, I just received power on feedback, and it's triggering the buttons back and forth. So yeah, Hercules is a great little test program for that way I don't have to physically go on site and connect to a TV or connect to something else. It's a great way. And see how I'm like triggering, I just disconnected with Hercules and it said error. Okay, step 3, hit pause and just copy the program if you either made a mistake or, you know, with all my errors. But anyway, I promise you this is a working program. So yeah, hit pause, copy it, do what you want with it. Hopefully it gets you down the road and you can modify it and put in better error checking and other things and use it for future modules. I hope that this information was helpful and that you can take this information and reapply it on your next project. And thanks for watching Arctic's 8-Bit Bytes, where I'm pleased to be your Internet AV engineering and programming resource. If you enjoyed this video, please click like and subscribe for more AV related content. Thank you.